Hello viewers, welcome to my YouTube channel. My name is Oluwashina Oyinira. In this video, I'll be talking about backtracking algorithm. So what is backtracking algorithm? It is actually a technique for solving problem by exploring all possible options and abandoning those that fail to satisfy the constraint. What am I saying? Now, you want to solve a particular problem. The first thing is to itemize the problem, is to analyze the problem and explore all possible solutions. One, explore the first solution. If it's going to work, if it doesn't work, then try another solution. Uh, Take for instance, you are in a maze and you have a starting point. Then you explore the first part and you get to a dead end. Then you have to like backtrace your step to your initial point, then explore another part. If you explore another part, you will reach a dead end. That is false. Then you backtrace again, then go back to your initial spot until that is how you do it until you reach a true stage where you can navigate the maze. And all those times you are reaching you are reaching the dead end, it is recorded as false. And the only time you have a true state is when you have a solution to that problem. So in this lesson, I'm going to be using the NQ's problem. So the NQ's problem involving placing end coin at a particular end by end chessboard such that no two coins can threaten each other. This means that no two coin can be on the same row, column, or dialogue. So how do you implement this? So I have a snippet here to show that. I may not be able to explain this code line by line, but I'm very sure that I'm going to explain the solution and how we come about it. So let's start from here. Now we have this function. What this function is going to do is that it's going to check if it is safe to place a coin at a specific position, that is the row or column. So it's going to ensure that there are no other coin in the same row, upper diagonal or the lower diagonal to the left of the current column. Now, this is what this function we declare here going to do. Now, what does this function do? So this function is a kind of recursive utility function. It attempts to place the coin column by column. That is, if it places a coin and finds a solution for the next column, it returns a true value. If not, it backtraces and removes the coin and tries to put it in the next row in the current column. So this is what this function is going to do. And what does this function do? So this function, it's going to initialize the board, call the utility function, and print the solution. Now, so the output is going to be a kind of 4x4 matrix that shows the movements. So let's see. Now, this is, which implies that for this position, for this, the coin can be here, can be here, can be here, and can be here. So let's try something else. Let's test another value like 8. Let's say 8, and let's see what is going to happen. You see, so these are all the possible solutions on how the coin can navigate without having any problem. So, and this is how backtracing algorithm work. It will first go to the initial stage, navigate the first option. Then if there is a dead end, back to it again, to the initial stage again, try the second option until it exhausts all the options. So that's backtracing for you. So thank you for watching my video. My name is Oluwashina Oyinira. Once again, I would like you to subscribe to my channel, like, and share with your friends and family. If you have any question or comments, or you think there's a better way of implementing this, let me know in the comment section. Thank you.